Hi, everybody. You guys want to take some questions from homeworks here to start? Anybody got anything? Questions from homeworks? No? Well, let me ask you guys a couple of questions then. Let's say that I gave you a vector represented by 2 points. Oops, not that one. That's not what I wanted. And I asked you to write the component form for the vector. Who remembers how to do this? What's the formula? X2 minus X1. Yeah, it's head minus tail, right? How do I know which one is the head? It's in the picture, right? The arrow, the head of the arrow is over the head, so B is our head. And the tail of our arrow is over the A, so that's our tail. Okay. So you see the arrow above the.
Okay, that's what I thought.
Yep, that's okay. Hey, look, I was just answering your question. You don't have to. There's, yeah, they are. So when I do head minus tail for the x's, it's going to be 5 minus 3. And for the y, it's going to be -4 minus 1. So I get 2, -5. That's my component form in the wedge brackets. Can we do that?
No.
It's just head minus tail.
Wait, it's head minus.
Yep. So it's like the x head minus the x tail, the y head minus the y tail. Right? Okay.
Is this the quiz question?
I don't know. Maybe.
Can we use notes on this?
No.
Oh.
Can you remember?
No.
Yeah, that's a bummer, isn't it? All right. Can you? It's not going away permanently. Do you know how to find the magnitude and direction for a vector?
What is magnitude in that first place?
Magnitude's like the length, like how long it is.
Okay.
So what is the magnitude? How do we find that?
And then it's a minus 0.
Yeah, just like x squared plus y squared. It's the square root of x squared plus y squared.
Oh,
That's it.
that's okay.
So 3 squared is 9, -4 squared is 16, 9 plus 16 is 25, and the square root of 25 is just 5. Arithmetic? That's the part you're complaining.
Yeah, it's the hard part.
That's the hard part. Okay.
It's really hard.
Okay. All right. So that's magnitude. If I want direction, what do I need to do? I'm going to start by drawing a picture. So when I draw the vector 3, -4, where's the tail of that vector located? At the origin.
Wait, so 3.
And then I'm going to go 3 over and 4 down.
Wait, I have a question. Oh, never mind. I figured it out.
Okay. So I've drawn a picture of my vector. Everybody okay with how to draw the picture?
Then why is it down that way?
I did 3 over and 4 down because it's the vector 3, negative 4. Just
like over 3 down 4.
Oh, I get it. It's hard. It's fine. It's
just like plotting points. Exactly right.
It's not exactly what it is.
So my direction then is going to be this standard position angle.
Oh, okay.
Okay?
Read the direction.
The direction of my vector u is going to be that standard position angle.
Okay.
So to find that angle, I'm going to need to find this angle alpha. And I noticed that that is right next to 360 degrees. Is that angle theta more than 360 or less than 360? Less, because it's not a complete circle, right? So that should be
Relax. It is not that deep.
should be 360 minus alpha. And we find alpha always the same way. Tan inverse, absolute value, y over x. So I just pull up my calculator,
I can actually do this all the time.
make sure I'm in degree mode.
It's always 10.
Yep. 360 minus tan inverse, and I'm going to do the absolute value just in my head. The absolute value of negative 4 over 3 is just 4 over 3. You can make things that are negative positive, right, in your head?
Yeah.
Yeah, right? No big deal. So I have like 306.9 then.
So we have this. So okay, so he did these, and then he put those there, and now they're here. Yeah. For some reason, I don't remember why. Are there plus? Yeah, it's you have to do it. Next question.
I love this. Yeah, next question. Can we, who knows how to go from a magnitude and direction to a component form? Only for the people listening to you guys jibber jabbering the whole time. I mean,
to do it so that we do 4 cos 218 and then comma sine or sine or 4 sine 218.
absolutely right. So to go from a magnitude and direction into component form, all we do is we do the magnitude times cosine of the direction.
What are we finding here?
We're writing the component form of the vector given the magnitude and direction.
I feel like I didn't understand math better if I understood what you want.
Understood why? What? So like, why would I want to do this?
Like, why do I need to know the vector? This is finding the vector? It doesn't matter.
So, okay, let me just grind through the number here and then we'll take a pull out for a moment and take the wider view for you guys to give you a little bit of context. So I have negative 315 and negative 246. And that's all we have to do.
So is it just the same with the number 12? Like how do we do it with the
So,
it's just the same thing with the fraction?
so that is a radian angle measure. So the only difference with your calculator, you change it to radian mode, but you do the exact same thing. So just change the mode of your calculator, but the formula stayed the same. Does that feel okay?
Should we change our mode now? Or?
Yeah.
I would just leave it in degree mode. Brody, what were you saying?
I'd ask if it was
Yeah, always cosine for x, always sine for y. Yes, every single time. Just like it was with the unit circle, right? Cosine was the x coordinate, sine is the y coordinate. Same idea here. So, to just kind of give you a view from the a higher level view, we have different ways to represent our vector. We have magnitude and direction. You have component form. You have 2 points. And you have like linear combination, which is what we talked about in the last, right, in 8.2, but that's not material right now. So what we are talking about in this chapter is really just like how to go back and forth between these different representations of a vector. And the reason you want to be able to go back and forth between them is sometimes, depending on what you're trying to do with your application, one of these forms may be more helpful or easy, make the problem easier than another, or might be more meaningful, like its actual real life number means something to you more than the other.
Is that a C or a G?
It's LC for linear combination form. That's that AI plus BJ form that we talked about it in 8.2. I think we did that. With the unit vectors attached to it. And the reason you care about vectors, probably you don't, but like most physical real life objects interacting with one another can be represented using vectors. And to predict what's going to happen, like when two things run into each other, or if you throw something, where is it going to land? Or, you know, like these type of questions are most easily resolved using this mathematical framework. So it's like essentially it's the language of physics is spoken in vectors. And physics kind of describes how our real world, things in the real world behave. So probably not to a normal person's everyday life, not super material, but neither is like being able to read a Shakespeare play or, know about the foundation of medieval Europe or, many of the things we learn in school, right? So much of what we're learning is just like, here's a framework and we're kind of teaching you how to learn, and figure out like what's important and what's not important and how things relate to one another so that you can take that abstract process and apply it to something that you actually have to deal with in your real life. Francis, does that help give you a little better overview of like the why? Or no? But you appreciate that I tried?
Yeah.
Okay.
No, this has been great. I'm really excited for this semester.
Well, here's what I'll tell you. What we're doing right now, I think, is the hardest thing we do in this semester.
That's what they always say.
No.
Like, I'm so tired of being lied to.
I am not. Hey, listen to me. Listen to me.
It's the hardest thing we're gonna do. Okay.
I think this is the hardest thing we do in second semester. Yeah. Get it over with.
It's gonna get harder.
I don't know.
You're gonna teach me new stuff, and then it's gonna be hard.
The next topic.
Wait, can you do like a component from the vector question again?
Yeah. Sure. You just want to do another, like, let's do 13. So it's going to be the magnitude, which is 5 over 2, cosine of the angle, comma, magnitude times sine of the angle. And then it's just calculator time. Punch it into your calculator and go. Is that okay, Mira?
Yeah.
Negative 24 was given to me in the problem. That was the direction.
Where'd you get 29? Is it a problem? That's 24. Oh, sorry. I wrote 29.
It's probably just my bad penmanship. You know, I understand that it's not always the neatest handwriting in the entire world. So that would be 2.28 comma negative 1.02. Yes, that was just like the very first one that we did, the head minus tail.
Oh, okay.
That's all we're talking about, going from 2 points to component form is just head minus tail.
Okay, and then the ONC is same as the.
I wouldn't worry about it for today. How about I tell you that? Is that good enough?
Yeah.
Okay. So what we did here is essentially the quiz. Okay?
Oh no.
So take 2 points and turn it into component form. Given a component form, find magnitude, find direction.
What's the component form?
It's with the wedgies, the little wedge brackets.
Okay.
That's component form. Okay?
Which one is the one where it's heads minus tail?
That's taking, you're going to go 2 points to component form.
That's component form?
So head minus tail takes 2 points and puts it into component form.
Wait, so like if there's a question where I have to do that on the quiz, I'm gonna get it right.
Good. You might get one right then.
So for the magnitudes, are we squaring?
That's the.
Yeah.
You just square both of them?
It's the square root of the x's squared plus the y squared.
For like the direction, what's used for that one?
That's you graph, and then you do like
You subtract it from.
k times 180 plus or minus alpha.
Okay. Wait, so if it's like going to magnitude and direction, is it always from the column?
From component form? Yeah, typically that's like, so like that's usually like the central hub, like kind of anything you want to do is kind of going to go through that
Okay.
because it's, everything is easier once you're in component form.
I actually learned 2 things.
I'm really excited. It's been a banner day then.
So the last thing we just did is like component form?
So the last thing we did was, you know, this spot here.
This picture's really
Awesome. Awesome. I'm glad.
No, look, you just have like to go all.
Are you gonna leave that up there?
No, there's like a funky little trick where you way. Like,
Yeah, you just pick the right
Where's your
procedure.
they're all different. That's why it's dumb.
That's fine.
You should memorize like 40 things.
Okay.
Quiz time!
I think that's right. You guys want to clear your desks for me and we'll get this thing out of the way? Oh!
So tail, heads minus tail, and then x squared plus y. Those are the
Oh, I'm gonna move that down. I pressed the button, it just must have missed.
You love me?
Just stop.
I'm trying to Wait, how is it?
Yes. The 15th. I know it's 8th hour, guys, but I'm not trying to make this harder than it needs to
What is
be.
it? Is that what
What? I mean, it's the last hour of the day.
I don't know who thought it was a good idea to put in a laptop.
You are a lot more talkative than you were the second hour.
Sleep, like, oh my god, I just want to leave. Oh. I'm sorry, I love this class.
You don't have to love the class. You don't have to sugarcoat it for me.
No, I really do.
Question.
Okay, what's up?
So I do -2 minus 6.
Which one's the head and which one's the tail?
-2 minus 5.
Is A the head or is B the head?
Isn't A the head? No, B's the head.
Okay.
Okay, so I do -6 minus 2.
Well, minus a -2.
Well, yeah, so plus 2.
Okay.
And then
Great.
that one. And then I add those together. And then that's it. Right?
Well, then you have to do the same thing with the Y's.
Well, yeah.
But yes,
This.
that's it. That's it. That's it. Nothing to it, right?
Do I write like -6?
You can write it that way, but we know a minus and negative is the same thing as. Mm-hmm.